in organisms, well, in any of these systems, what happens? Energy and resources come in, that's metabolism. It gets put into a form that can be used and then sent through networks to support the individual constituents, cells or people, whatever. So, but what does it do for those constituents? Well, it maintains those that are there, repairs damage, and replaces ones that have died, whether they're, again, cells or people. But it also grows new ones, new cells, new people, and so forth. So if you put that into mathematics, that statement that I made, then it turns out that you can explain the structure of the growth of organisms, why it is that we grow very quickly at the beginning, and then we stop growing. And the cessation of growth is driven or intimately related to the economy of scale, the sublinear behavior, this 3/4 being less than 1 of the scaling of metabolism. That ensures that you stop growing. Now, let's take that idea and go to social system, to a city in particular. You have the same conceptual equation. Metabolism goes to maintenance and new growth. But when you do that, what you discover is instead of the bigger you are, the less supply per capita to something that needs to be maintained so that it eventually stops. Now, the supply always outpaces the need for maintenance because of superlinearity, because of this added 15%. So you're getting further and further ahead of what you need just to maintain. That means that you have open-ended growth. Just keep going. And so this drive to get new things, continually getting new things, to continually replacing, things that are perfectly fine, often people get rid of their car after 2 or 3 years, doing just fine. Or, you exchange your iPhone 5 for an iPhone 6, and this year you're going to replace it by an iPhone 7 with probably decreasing ability, relatively speaking.